Okay, so I will take you to a journey into steel industry and the purposes of water in steel industry. Today we heard from Sophie the importance of water in steel industry and the issues we have to deal with, meaning that we have a decrease of water availability and we have challenges regarding the composition of the water, and we are looking for solutions to decrease the freshwater consumption and recover water as much as possible. So in these two projects we were talking about SpotView, we were taking a look to a complete site, taking a look where we can recover cooling water, and in INSPIREWATER we focus to one cooling water circuit which has to deal with special issues regarding corrosion and scaling. So when we are looking about what are the challenges in this situation, that we have an intake of different components as a solid and grease into the water, we had to add some chemicals to operate these water circuits, and we have to add the concentration of solids and hardness forming components leading to corrosion and scaling. And as you can see, we have a complex mixture in these cooling waters, and this leads to a problem if you would like to apply just conventional technologies. These cannot work efficient on this kind of water. So the idea was to use innovative technologies as the capacitive ionization, for instance, and to optimize the water management and recover and take water from alternative sources. So the aim of saving water is all known, and decoupling production and freshwater demand is one of the most important issues, and I think this has to be soluted, but solutions will take time and new challenges will come up. So what technologies did we use? We used a magnetic separator for the removal of particles. It's operating chemical-free and pressureless. That means we will save energy compared to conventional pressurized filters. Then we had another solid removal technology. It's a combined flotation and microfiltration. The special thing is here that you are removing oil as well. So these two technologies are mandatory steps for desalting afterwards. So independent from the technology you would like to use for desalting, you have to have a special kind of water composition, and this requires removal of solids, removal of organics. Further on, we had the capacitive ionization. It is based on electrostatic adsorption. That means you are collecting the ions on the electrodes in one period, and you have a short time of regeneration where you will release this ion again in a kind of concentrate which can be discharged. And the last technology was the innovative reactor, which is based on a high-frequency electrical pulses, which will affect bacteria in the kind of being destroyed and change the water and particle charge, that the particles will not stuck to the tubes in any way. So what did we achieve? We performed field trials, and in lab always things go very well. So the thing is, let's demonstrate it at the site and not just a short time, just demonstrate it about a time of 4 to 6 months. And we did it in INSPIREWATER with the 4 technologies you can see over there. We have the 2 technologies for the removal of the suspended solids. We have the reverse osmosis for desalting, and we have the innovative reactor for disinfection and decrease of scaling. So finally, what we did achieve in half a year of field trial is about treatment of 31,000 cubic meter of cooling water, and we were able to achieve solid contents less than 15 milligram at the outlet, independent from the varying inlet solid content. And what we further did achieve was a very high solid content in the sludge we produced, about 31 weight percent compared to 0.2 weight percent to conventional sand filters or multi-layer filters. And we had only just a very low amount of occurring sludge. That means you have a very reduced amount of sludge for post-treatment. The three-layer filtration is a very nice option if you have existing sand filters and you would like to enhance the solid removal. Just change the inside the sand by 3 different layers of materials, and then you can increase the solid removal from 65 to 96%. Or the other option is to decrease the velocity as far as it is possible. With the reverse osmosis, we treated the water which was produced by the magnetic separator, the three-layer filtration and the operational sand filter, and we were able to recover about 80% of the water and fulfilling the requirements from ArcelorMittal to reuse this water again. Sadly, that's the research. The innovative reactor did not show conclusive results in the lab and field trials. Further on, in SpotView, we took this holistic view. We were focusing on cooling water. So we had 3 different approaches. One was to recycle water. So you can see on the left-hand side. And the idea was to recycle water, backwashing water, which is loaded with suspended solids with several hundred milligrams and as oil as well, and then dissolve it and use it again in the process. The second approach is to make a cascade reuse, meaning an optimization of the water management, taking a look to the cooling water circuits and saying, okay, blowdown from this cooling water circuit can be used directly, for instance, in another cooling water circuit with lower requirements regarding water composition. And finally, we have the saving of fresh water, saying, okay, let's take a look to seawater, rainwater. What should we have to do with this water before we can resort it, and determine suitable technologies for regarding solid removal and desalting. So we produce with the CDI, capacitive ionization and reverse osmosis, different waters. And as you can see here in the green fields, these are all the applications. We can use the water we produced by CDI and reverse osmosis in different purposes, because all these different cooling water purposes has different requirements regarding conductivity and chloride content. In all cases, we fulfill the requirements from ArcelorMittal to reuse this water internally, and in some cases we have just the adjustment of pH values. And in one case, we have a very special and very hard, high requirements regarding water composition. But mainly, we can use the water we produce with CDI and reverse osmosis for further cooling water applications. Here you can see some data, what we achieved regarding the backwashing water. You can see the flotation with microfiltration. We recovered 98% of the water with a very low energy demand of 0.3 kilowatt hours per cubic meter, and suspended solid content less than 3 milligram. CDI and reverse osmosis both allowed the production of a water quality which can be reused in the cooling water circuits of ArcelorMittal, and we had zero recovery rates between 78 and 85%. Regarding the energy demand, CDI was lower than reverse osmosis with 0.95 to 1.4. And further on, we determined seawater and river water treatment methods to recover this water again. And as shown on the figure before, for most of the applications in the area of cooling water, we can use these kinds of produced waters again. So when we are coming to the summary, then of course we saved 66% of the energy in INSPIRE water by using the magnetic separator. We recovered 80% of the blowdown and 30% of the fresh water by treatment of the blowdown with the IRO. In SpotView, we managed to save water in the range of 30% and 80% by desalination. Backwash water we recovered with 89%, and with the shown technologies, a combination of microflotation and flotation, followed by desalting by reverse osmosis or capacitive ionization, and finally the dependency between product ton of steel and water was reduced about 50%. So if we take a look to these results, we can say we achieved the things we promised. The results were very good in the area of cooling water, but are now all questions soluted? The answer is no, because we still have a lot of different waters in steel industry, like gas washing water, which are much more challenging than cooling waters. We have waste waters from other purposes, and we need further developments of technologies which allow to recover these waters as well.
Thank you, Martin. Is this your conclusion? Because we have...
Yes, just one picture to say thank you to all these people enjoying taking part in these projects.
Thank you very much. So we have some questions from the audience. So the first one is, what kind of material are used for the 3-layer filtrations?
It is a kind of sand, it is a garnet and anthracite.
Okay, thank you. Maybe you can write this. Then do you have figures about the total cost for the purification of water per cubic meters? Or
we do not have...
maybe tomorrow will be.
Well, I just given a range. The costs for desalting with capacitive deionization and reverse osmosis are more or less on the same level.
Okay, and the last question is the average consumption of water per ton of steel produced, or the range?
It depends on the site. It's between... We have everything from 8 to 40 tons. 40 cubic meter per ton of raw iron, but it depends on the site, it depends on the local conditions, and it depends how the people are counting the water. Some people consider this and this water circuit inside, others not. So this is the reason for this big range.
Okay, this is understandable. And my last question would be, what are the needs for monitoring and process control if you want to implement this type of technology?
Well, it's desalting is one case, but we have two issues. One is to see what is the optimum place to reuse this water, and if you have a complete site, then you have dozens of different water streams, and you need a kind of simulation which is making a prediction to say, if we produce water in a certain quality, we can use it this or there in another place to optimize the water management and the water reuse internal. And the second thing is, when we are desalting, we are producing concentrates, and we have to find solutions for these concentrates and make a valuable material from that. For instance, like biocide production. So these are the big issues to increase and enhance the realization at the sites and develop further than the stage we have achieved right now.